Okay, so we're up to the final question on tutorial 10. Assume that S of t is a geometric Brownian motion. Usual stuff. We're given the model for the share price. Consider the geometric average, which is the product of the share prices at the nth root. So 5 share prices multiplied together, take the nth root. This is the geometric average. Find the expected value of log of g. Okay, so let's calculate the log of g. So this is the 1/5 comes down, and the log of a product is the sum of the logs. Giving us this equation. This is an arithmetic average using logs. And we know each of these log of S 1, 2, 3, 4, 5 from our explicit formula. So if we take logs of this, we get the following. Okay, and we're now ready to compute the expectation of log of g. Okay, so combining these two things, we have the log of g is 1/5 log of S1. Well, log of S1 using the second equation is log of S0. Substitute 1 into here and 1 into here. Okay, keep going for each of those t values as 1 to 5. We have 5 lots of the first term. Then we have 1 of these, 2 of them, 3 of them, so on and so on, up to 5 of them. And finally on the end, we have B1, B2, B3, up to B5, lots of sigma. Don't need another bracket. Yeah, one more. Okay, so this is our expression for the log of g, and we want to take the expectation. So let's do that. So take the expectation of both sides, the log of g, expectation of that thing. Okay, so let's calculate. Okay, so we have a constant at the front, which is 1/5 of 5 log S0. The 5 and the 5th one cancel, giving us log of S0. Okay, this sum is 15. 6 times 3. 6 times 1, 2, 3. How many we got in there? 5 terms. Yeah, that's 15. 15 with the 5th at the front is 3. Okay, that's that one. What else do we have left? We now need to, let me think. Oh, we need the expectation, that thing on the end. The expectations of the last term is that 0? Let me think. Yeah, that's 0. Oh yeah, the expectation of each of the b's are 0, of course, plus 0. So let me just make a note of what was going through my head there. So we're using the following results. The expectation of a plus bx is, well, a is just a constant, b is a constant. If you take the expectation, the a stays where it is, the b comes to the front, and we take the expectation of x. This always works for real numbers, a, b, and x, just any random variable. And of course, the result, which I almost forgot, the expectation of each of the b's is equal to 0. Okay, so that gives us this result. Okay, so that is part I. Next, part II. We want to find the variance of the log of this value g, the geometric average. So let's do that next. Okay, so the variance of log of g. Let's take a look. Well, if you take the variance of a constant plus some multiple of a random variable, the constant disappears. The constant in front of the random variable becomes squared. So I'll write the answer, then I'll explain why. So we have the first terms are constants, so they will disappear. The sigma becomes squared, and this is sigma over 5. And then we take the variance of each of those b's and sum. So what have I done there? Let's take a look. I've used the variance of a constant plus a constant times a random variable. The first constant, a, disappears, and the constant in front of x becomes squared. I'm just using this rule. There's no obvious rule for the variance of the b's, but what we do know, which we need to somehow build into our calculation, we need to utilize the fact that the increments follow the normal distribution, and the variance is just the difference in the times. We somehow need to build this into our calculation for the variance of the sum of the b's. Okay, so it makes sense to state some variables which we do know the variance for. So we do know the variance for the increment, b1 to b0. Well, b0 is 0, so that's just b1. We do know the variance of the increment b2 take away b1. So I think I'm going to give these names. I'll call this one b1, I'll call this one b2. Again, we do know the variance of the increment b3 take away b2, so I'm going to call that b3, and so on for everything that we have. Okay, that's everything we have. All these are the independent random variables, and let's make a note of this. These are independent random variables following the normal distribution, and the variance and standard deviation is 1. This comes from definition. Start with definition. Okay, so we need to utilize this. So we need to take our sum and rewrite all of this using the left-hand side. Okay, so what trick should we use for this? Let's take a look. So, this needs a little bit of thought. So if we substitute this one into here, we will get B5 take away, oh, maybe it's not the best way to say it. Okay, so that's one way to approach it from the back, work our way to the front. How about from the front to the back? So if we put this one into here, so we have, yeah, I think from the front is better. If we put B1 into B2, we get B2 take away B1, and then if we put that into there, that into there, and that into there, then what we're going to find is we're going to have 5 lots of B1 because we've subbed the first one into each of those. We're going to have 4 lots of B2 because that's been substituted in 4 times from the second line. 3 lots of B3, 2 lots of B2, and at the end just 1 lot of B5. Okay, so I think that just takes a bit of playing around with to convince yourself that is the case. Let's put 1 there for symmetry. Okay, once you've convinced yourself of that, we're now ready to take the variance. Okay, so we know it's sigma squared over 25, and we can use this above identity, so we get 25 times the variance of B1, 16 the variance of B2, just squaring the numbers in the front, so on and so on. 9, 4, 1. And the variance of each of those b's is just 1, so we have the sum of these square numbers giving us the final answer. Okay, a bit of adding up. 55, yeah, 11 for 5 sigma squared. Okay, so the final answer is 11/5 of sigma squared. Okay, and that completes the question.